Hey everyone, it's time for 9.3, the last section in chapter 9. Woohoo! This one's all about the coefficient of determination. All it is, the calculation of it anyway, is r squared. Okay, so you already know how to find r using StatCrunch. The coefficient of determination is just squaring that number, and then we'll get into the interpretation of it as well. It's talking about variation, a ratio, explain variation to the total variation. But when I give you the structure of the interpretation, it'll make more sense. Here's a little example. Let's just assume as far as the calculation goes, you have r squared is 0.9. R is 0.9. Then notice r squared is just 0.9 power of 2, 0.81. And here's the interpretation right here, okay? This means that 81% of the variation of y can be explained by x, all right? That's what you would write out, okay? So it is how well the explanatory variable x is doing to explain the y, the response variable, okay? So just like r, the higher the percentage, the stronger the correlation, right? Okay, let's do an example. Rely on StatCrunch for these. And I went ahead and put all of the pieces in here as well from 9.1 all the way through 9.3. So we've got the relationship between length and weight of a collection of 8 bears. And then we're going to answer all these questions. Correlation coefficient, linear regression, make a prediction, coefficient of determination, the new thing, and then work on that interpretation of that value, okay? So let's jump to StatCrunch. Again, this one is in your StatCrunch folder if you want to play along. So I've got that loaded right here. Let's bring it in, okay. Guess what? Where you go is stat, regression, simple linear. All of chapter 9 is that one StatCrunch feature. Okay, so I'm putting my length x, weight is the y. I could also do a prediction. Right? Part C wants to predict the 70-inch bear, so let's put that in there. By the way, don't worry about this level when you're doing that prediction. It won't matter. That would matter if you're doing a prediction interval, but we're not doing that, so we're good there. Okay, here's our report. Notice it also does just give you the r squared right there. So you don't actually ever have to square the r. It does it for you in StatCrunch. But it's just simply that squared. Okay, so I've got my correlation coefficient. That's part A. Looks like 0.8974. And then I got my linear regression equation. Again, you can, when you write it out, don't worry about putting the words. Just use the y and the x, and then put a hat on the y. Right, so I'll be right. Y hat equals negative 351.66, and then plus the 9.66 x. Okay, that's your regression equation. Predict the weight of a 70-inch bear. I could plug the 70 in for the x here, or I just did it with StatCrunch. There's your prediction. When x is 70, the predicted y is 324.5. So I can write that down for my part C. 324.5 pounds. Okay. By the way, if you're curious about all this other stuff that you're getting, that some of it we're not doing, but this right here, this is called a prediction interval. And it's a 95% prediction interval. right? That's like a confidence interval from chapter 6. So we're 95% confident that the predicted weight is between those two values. Okay, so our point estimate is the 324. But if I want to express that with some margin of error, I could use that prediction interval. Okay. And then there is the confidence interval, prediction interval, confidence interval, kind of similar. Okay, but we're not really covering that, just FYI. Continuing on, R squared is right there, so that's my part D. Let's see, it looks like a 0.805. Let's just take that one to 3 decimal places. 0.805 there. Okay. And then we'll get to the interpretation. All right. So let me jump back to my handout and I'll show you what I have written down. The interpretation part, use percentages for that. So we're going to convert that R squared to a percentage. So 80.5%, or if you even wanted to say 81%, right? That's fine. So in this interpretation, about that percent, about 80.5% of the variation in the, so this one talks about what the y variable represents. 80.5% of the variation in the y variable, or in the weight, can be explained by the variation in the explanatory variable, the length. Okay. So in this interpretation, the y is always going to be first. Right? So this is the y variable, and this is always the x variable. Okay. And then what percent is just unexplained? Well, it has to add up to 100, right? So you're just going to subtract 80.5 from 100, and that's going to go there. So that's 19.5%, right? Okay, no problems then. So that's really a lot of the pieces of chapter 9 right in that one problem. Okay, let's try one more. This last page here. Oh, there's one more concept too. It's called the standard error of estimate. There's a formula for it. We're not going to use it, of course, unless you want to try it out. Again, we're focused on technology in this section. We do want to get the interpretation right, though. Okay, so we'll get to that when we do the fill in the blank thing here. So for that bear example, let's find S sub E. It's called the standard error of estimate. It's a standard deviation of the observed values about the predicted values. Your StatCrunch output gives you that value too. Woohoo! Okay, so if you look at your StatCrunch output, I'll show you where that is. I think it's right towards the end there. There it is. It's called. They call it in StatCrunch the estimated error of standard. The estimate of error standard deviation. Okay, that's what they call it. So in this example, it's 66.6. Right? And the unit of measurement for this is always matching the y value. So that would be 66.6 pounds, since the y is the weight. Okay. And the interpretation of this is that the standard error of estimate for bear, so yeah, kind of like the last interpretation, put the y variable first. So that the standard error of estimate for bear weight for a specific bear length is about that value, 66.6 pounds. Okay. So for a specific length, the standard error estimate for the bear weight is 66.6 pounds. So again, remember what standard deviation measures is spread of data, right? On average, how far are things away from the mean? Okay. That's a B right there. Okay, now let's try this last one. We've got a new set of data. Table shows ages versus salary. All right, we're gonna run through everything here, okay? So I'm gonna bring it up in StatCrunch and you can follow along if you have this printed out. Going back and forth here. Okay, so again, we need the data into StatCrunch. And that one, again, is in your groups folder as well. So there it is, got it loaded. We're doing our regression, stat, regression, simple linear. My X variable is the age, and my Y variable is the salary. Are we going to do any predictions? Yep, there's a 45 prediction. So I'll put the 45 there for the X value, and then that's it. Don't worry about the other stuff. Okay, and there's my output that I'll be using to answer all these questions. So correlation coefficient, 0.9227. Okay. Linear regression equation, y hat equals, looks like 21.47 plus 1.33 x. Okay. Predict the salary of the 45-year-old. There's your prediction, 81.2. Now, if I'm actually answering this question, what is the salary? Remember, it's in thousands of dollars here. It's $81.2 thousand. So I could write that out. I want to make sure I label this. It would be in dollar, 81.2 or $81,200, right? Or $81.2 thousand. Okay. The coefficient of determination, where is it? R squared. That looks like 0.851. Okay. The interpretation of that, so about 85.1% of the variation in the Y value, salary, can be explained by the variation in the X value, age. Right? And then the other, what is that, 14.9% to add up to 100 will be unexplained. Okay, and then the standard error of estimate, the S sub E is that last value. It looks like 5.09 right there, right? That's that one. So we're gonna go with 5.09. And remember, that's in thousands of dollars, right? So think of that as about $5,090, rounded to the nearest $10, right? Okay, and then the interpretation of that, and once we're done with this StatCrunch, so I can jump back to my handout. You can see what I'm writing. The interpretation of that is the standard error of estimate for Y value, salary, for a specific age is sorry, that's my dog barking. Shh, come here, bud. $5,090. Okay, so before all gets crazy around here, go ahead and check out the answers to that. And I think we're pretty good there. Okay, so give chapter 9 a try. If you have any questions, let me know. I got my dog in my hands, and we're gonna call it quits right here. Okay, hope all's well. Later, guys.